Alright guys, so we're going to start our video about the large qualitative analysis lab that we use as our last activity of the year for chemistry. What you should be given, if you haven't gotten it already, are 3 pieces of paper. So the first piece of paper has 3 columns on it. This right here is a general overview of the lab, how it's graded, what we look for. So we're going to go over this one first. The second piece of paper is background information on procedures that you have to know to be successful in the lab. It's 2-sided. And the third piece of paper is the actual laboratory procedure that we're going to do. So I'm going to go over a first piece of paper with how the lab works, how it's graded, and then we're going to go over certain parts of this paper about the procedures. I'm going to show you a couple procedures that you're going to do in the lab. And finally, we'll chat about the procedure a little bit, but you can read it, so we're probably going to let you read that for the most part. All right, so our qualitative analysis lab. So the difference in qualitative and quantitative is that quantitative uses numbers and qualitative does not use numbers. So this is a qualitative lab, which means that you're not going to be doing very much math at all in this lab other than counting drops and just keeping track of where you are. What a qualitative lab does is it identifies the presence of something, but doesn't tell you how much of something there is. So in this lab, you're going to be given 4 ions: aluminum, chromium, iron, and nickel. And you're going to go through a test to identify each of these ions, which we'll get to in a minute. So this lab is 4 grades: 2 test grades and 2 quiz grades. And the grades are split up as follows. After this video, and after you've read these papers, you're going to know a fair amount about what you're doing in this lab. Before you start the lab, you have to take a test on all the lab knowledge. And it's going to cover what you do in the lab, how you use the equipment, what chemicals you use at certain times, and safety questions, as well as just general knowledge on how the lab is graded and completed. Now, that test on that lab knowledge is a test grade, and you have to pass it to start the lab. So, if you pass it the first time, we'll say good job. The grade will go into the grade book as a test grade, and you start the lab. If you fail it the first time, that failing grade goes into the grade book, and then you have to go and study some more. We allow you to take 2 tests a day, but there has to be 30 minutes in between when you finish one test to when you start the next one. So if you take a test and you fail it, you can't just go like, all right, give me another one, I want to do it. So if you fail a test, we're going to say, go back and study. You have to study for 30 minutes, and then you can take it again. It will not be the same test, though. We have at least 10 different tests that that are based on this lab that we're going to use to judge your knowledge. Now, we have this video, and the video will be posted on Google Classroom, so that you can obviously watch it as many times as you want to. But the teacher will also be in class to explain the lab and answer questions when the lab starts. Now, we'll answer questions, any question that you have, up until the first test is given. Once that first test is given, we're done answering questions about the lab for the rest of the year, unless it's a safety question. If it's a safety question, we're going to answer it. But if it's a test on like what reagent do I use for this chemical, or how do I run this piece of equipment, or how do I know how many drops to use, we're going to say, go read your lab, or go ask a peer, or maybe go watch the video again. But we're not going to answer it. It's going to be on you once the first person takes the test. Now, we're going over this stuff on a Friday. The first day that you can take a test is going to be Monday, May 8th, the beginning of the class. Now, if somebody decides to take a test as soon as class starts, then the teacher is done answering questions. But if it's halfway through the period before somebody decides to take the test, then that gives you half a period to ask questions of your teacher. Now, After you take the test on the lab knowledge, that test grade, the first test grade, goes into the grade book. If you pass, then you're going to go into what we call the known portion of the lab. Now, the known portion of the lab is based around this chemical here that has the 4 ions that we're identifying: the aluminum, the chromium, the iron, and the nickel in it. And all you have to do is go through the lab procedure, which you'll have, and separate all 4 ions in the solution, do a test to prove that they're in the solution, and when you're done, you're going to have 4 test tubes, each one with each particular type of chemical in it, which will be a certain color or have a certain characteristic. Actually 5, because there's 2 tests for the aluminum. And you're going to bring it to the teacher, and you're going to be like, all right, I have my known. These are my chemicals. This is aluminum. This is copper or chromium. And your teacher may ask you, like, what chemical did you add to the aluminum? Or why is this one cloudy and this one clear? And you have to be able to answer those questions. Now, if you answer all those questions correctly, then a quiz grade goes into the grade book as a 100. And for this one, it's pretty much, you get a 100, or we tell you, go back and figure it out, and come back later. So after you're able to answer all the teacher's questions, and you've identified your ions, and this 100 goes into the grade book, then the teacher is going to give you a test tube. And it's going to have either 0 ions, 1 ion, 2 ions, 3 ions, or maybe all 4 of the ions. It's going to have some combination of the 4 ions that your known had in it, but some may be missing. And you have to, again, go through the procedure, and you have to identify which ions the teacher gave you. And when you're done, we're not going to ask you any questions. You're going to have your test tubes, and we're going to say, what do you got? And if you correctly tell the teacher what they gave you, then we say, great, 100 goes into the grade book as both a test grade and a quiz grade, and then you're done with the lab. If you miss it, we're going to say, nope, go back, do it again. If you get it right the second attempt, then you get an 85. If you miss it twice, but get it right the third time, you get a 70. And if you miss it 3 times, well, tough luck. That's going to be a 0 quiz grade and a 0 test grade. Now, for this known solution, I don't mean first attempt as the first time you go through the procedure. We're going to give you enough chemicals so you can go through it 2 or 3 times, maybe even more, to really understand what you have. We only grade it when you come to the teacher and say, I'm done, this is what I have. So that's how this lab is graded. And this is 2 test grades. It's a pretty big effect on your grade. Now, let's start doing a couple things in the lab, and let's kind of go through the background. Now, this qualitative analysis lab is actually called a Group 3 qualitative analysis lab. In terms of separating inorganic chemicals, we generally separate them based upon the solubility of a chemical in different types of solutions. And you did the solubility rules a couple units ago when we did net ionic equations. And as a general rule, solubility is based upon 3 big groups pretty much. There's solids that are precipitated out as chlorides or other halides. There's solids that are precipitated out as sulfides, and there's solids that are precipitated out as hydroxides. And then you still have some other kind of odd ones in there. Your silver, your mercury, your lead sometimes precipitate out a little differently. So it's called a Group 3 because if you have a bunch of unknown solutions, the first things that you can precipitate out are things that are insoluble as chlorides. So like your silver chloride, your lead chloride, stuff like that. So you would add hydrochloric acid to it, and you would pull those out. The next group, the Group 2 ions, would be things that are solvated out as sulfides in acidic solution. And you do that with hydrogen sulfide gas, which is pretty dangerous and pretty deadly, so we're obviously not going to let you use that. And Group 3 ions are those that are base precipitated. And that's what we're going to focus in on. We're going to precipitate them out by adding a couple different bases to them, actually 3 different bases to them, and that is going to make our certain ions of these 4 precipitate out. Now, after There's base precipitated ions, then you have carbonate precipitated ions, which are group 4 ions. Things like magnesium carbonate, calcium are carbonate precipitated ions. And then our group 5 ion is anything that's not precipitated out as a chloride, an acid sulfide, a base sulfide, hydroxide, or carbonate. Now, do you need to know that for the quiz? Absolutely not. You just got to know that, hey, we're using some bases to precipitate out. You don't need to know what the groups are. But it's a kind of neat little fact. So, we're going to start with how to use this equipment. Now, when you start the lab, there are a variety of chemicals, 10 or 12 different chemicals that you're going to have to know what they are and how to use. So, at each station, you're going to have a set of chemicals in a little white container here. And these right here, what we refer to as our stock chemicals. It's acetic acid, ammonium hydroxide, sodium hydroxide, hydrochloric acid, nitric acid, and sodium hypochlorite. The hydroxides are pretty basic, particularly your ammonium hydroxide, your sodium hydroxide. You don't want to get those on your skin. If you do, just wash it off. Your hydrochloric acid, your acetic acid, you don't want to get in your skin because it can cause some irritation. And nitric acid, you really don't want to get on your skin. And the sodium hypochlorite, you don't want to get on your skin or your clothes, it'll turn white. So, we have to wear goggles the entire time during the lab. You really don't want to get any of these in your eye. And we're pretty strict about wearing goggles. If we catch you not wearing goggles when you're in the lab, we're going to start taking points off of these grades. As a general rule, every time we catch you not wearing goggles, 5 points leave on one of these test grades. And we just have a list and we say, Susie's not wearing her goggles, 5 points off. And we just tally it up. And at the end of the lab, however many points you've lost for goggles, we just kind of subtract that off these grades here, and it is what it is. So, we gotta wear goggles. So these right here are our stock solutions. And if you run out of those, just let us know. We'll replace them. All right. Y'all should know what distilled water is. And you're going to see a couple of these. These right here are our known solutions. This has 4 ions in it. It has our iron, chromium, nickel, and aluminum. This big thing here is a centrifuge. We'll get into centrifuge operation in a minute. And then you'll need some small test tubes and a big test tube. As a general rule, we say to grab 5 or 6 small test tubes. We have plenty of these, but they're dirty. So if you ever grab a test tube out of the box, the very first thing you need to do is to wash it with some glass cleaner, rinse it out with a little bit of distilled water so that you don't have any contamination in there, particularly when you're doing your unknown. If somebody does this lab, has a bunch of aluminum, and they have it in a test tube, they just pour it down the sink and fill it back in the box, and you grab that same test tube later and you don't have aluminum, their leftover aluminum might show up positive for the aluminum test and cause you to miss one of your attempts. So you really need to make sure that your test tubes are clean before you start. Now, the small test tubes, we're going to say 5 or 6. You're going to get a cup or a beaker. It's going to be, you're going to label it. It's going to have your name on it. And they'll be yours, so you kind of know what you have. Now, there's also some big test tubes. These are kind of communal, so if you grab a big test tube, wash it out, but you're not going to keep it because we don't have enough to give every kid one of these. Now, there will be test tube racks around the room. You'll just grab one when you need it. These are test tube clamps. Most of you should have used these before. And these right here are our indicator solutions. And there are 5 different indicator solutions. There's barium chloride, there's dimethylcoloxamine, potassium thiocyanate, 8-hydroxyquinoline, and pyrocatechol violet. And each one of these is designed to indicate a certain metal. So like if you have nickel in your solution, you add dimethylcoloxamine to it, it's going to bind with that nickel, make a complex, and turn a certain color. And we'll go over closer to the end what chemical we use with each one. And you're going to use some stoppers. So I'm going to start just by pretty much showing you how we're going to kind of start this. I'm going to talk about a couple different things as we go. So first thing, when you start the lab, you're going to get your small test tubes and you're going to get a big test tube and it's going to be cleaned out. then we're going to say start your known. And if you read them aloud, first step says get 2 milliliters of your known sample. Now, we're not going to use graduated cylinders in this lab. It's just, it takes too long. So your known sample is here. So I need 2 milliliters. How do I get 2 milliliters if I'm not using a graduated cylinder? Well, the answer to that is we count drops. 20 drops equals 1 milliliter. And that's pretty important. You should know that. So, if I need, say, 40 drops, well, or 2 milliliters, then I got to count 40 drops. And it's pretty easy. You just count them up. So I'm going to put roughly 2 milliliters in here. And this is my known, so this has all 4 of my ions in there. And then I'm going to add certain things to the solution to make some things precipitate out. If you look at it, you can't see the video, I'm sure, but this right here is clear. Now, on our lab, the first thing we're going to do is we're going to add 2 milliliters of our sodium hydroxide, which is a strong base. And again, 2 milliliters is 40 drops, so I'm going to count out 40 drops. And what you should notice is that pretty quickly, that is not so clear anymore. Now, what we have to do is add our stock solution, our reagent, to this, and then we got to basically give it some activation energy. So we're going to give it some activation energy by heating it. Now, I'm going to heat it on this burner here. You're going to use regular muscle burners in the lab, but I don't have gas in here. Now, you do not want to just stick this right here over the burner. You'll burn yourself. So you're going to use a test tube holder. Now, when you're heating a test tube, and this is one of the most important things, it's almost on every single test we ask about this lab. If you're heating a test tube, you have to make sure you're not pointing it at yourself, or if you're not pointing it at somebody else. So we want to kind of hold it at an angle, and we want to swirl it when we heat. Now, in the lab it says to heat it for 2 minutes. I'm not going to heat it for a full 2 minutes because I don't want to just waste your time by watching me do this. But I do want to get it to boiling so I can show you kind of how it acts. Now, the reason we use big test tubes for this is that this has a tendency to do what's called bumping. When it starts boiling, if it gets overheated at the bottom, a really big bubble will form and it'll shoot out. And you can see it kind of doing it a little bit. The more we swirl, the less likely it is to happen. But we want to heat it for 2 minutes. Now, we want to make sure that we don't overheat this and cause it to splash out, or that we don't overheat it and cause it to basically drive off all of our liquid. If we drive off all the liquid, if it dries out, then it's no good. You got to wash out your test tube and start over from the beginning. So that's not too bad. I'm going to go ahead and add a little bit of hypochlorite to this. And if you're curious, I'm going to heat it again. Sodium hydroxide is going to take the iron and form an iron hydroxide complex to it. And it's going to take the aluminum and form an aluminum hydroxide, an AlOH4 complex. And the hypochlorite is going to oxidize a chromium ion to a chromate ion. Now, you can see here, it's like really splashing up, right? So if it starts splashing up, gets close to the top of the thing, I just pull it off, let it cool a little bit, and then when it kind of calms down, I'll put it back on there. And heat it just a little bit. All right, I'm going to add my other one. In the lab, it says to heat each of these for about 2 minutes, I think. Now, some of these are have some pretty strong smells to them, so don't bring them down. All right. So notice when I'm doing this, I'm heating this, I'm making sure that this test tube is pointed away from me. Now, if there's a lab full of people working, that can be kind of tricky. So you want to make sure you know where your test tube is pointing, and you want to try to make sure you know where everybody else's test tube is pointing as well. Because if this right here starts to splash out, you don't want hot chemicals on you. All right. All right. I'm going to stop that. Now, if you look in this, I have some chemicals and there's some solid stuff on the side of the walls. Now, I want to separate the liquid part from the solid part. Because in this case, our iron and our nickel, I think, should be solid. No, the iron and the, yeah, that's right. And the aluminum and the chromium should be still liquid. Now, we can't separate in this big test tube. So what we're going to do is we're going to pour it into a smaller test tube. Burner kind of heats it a little bit hotter than the burners in the lab rooms do. All right. Now, you shouldn't have to add water to it to pour it out. If it turns into a sludge, you probably want to restart, but for the sake of time, I'm just going to add a little water to it and pour it out. Now, in this test tube, there is solid and liquid. And to separate that into its components, we're going to have to use this thing called a centrifuge. Now, how a centrifuge works is that it has a series of 6 tubes that are evenly distributed on a motor. And if this is closed, this is going to spin really, really quick. Now, I'm going to do this incorrectly first to show you what it looks like. And then I'll do it the correct way so you can know the difference. Now, when you heat something with a centrifuge, you have to counterbalance the centrifuge. So if I have a test tube in slot 1 here, and it's by itself, so that one side is going to be way overbalanced or unbalanced from the other side, and it's going to cause this thing to rock. So if I put something in spot 1, then I want to put something else of equal weight in the spot opposite. You can do 3 test tubes, 4 test tubes, or 6 test tubes. You can do 2, 3, 4, 6, based on how many people are using it and how you distribute it. Now, I'm going to first show you a random test tube. I'm just going to put some water in this. And I'm just going to put it in a random spot and turn it on. Now, I've not counterbalanced this. So if I turn it on and got a timer here, a speed here, and I turn it on, it's going to start to speed up. And immediately, so if that happens, that tells you this unbalanced. You want to just stop it, unplug it, turn it off, and let it stop. It should be a smooth operation. If it starts to want to jump off the table, that's bad. So, to counterbalance a centrifuge, you have your test tube you want a centrifuge, and you're going to take another test tube, and you're going to add water. It can be distilled water, it can be regular water, until they have equal amount of liquid in them. So, I have the test tube I want to separate, and I have my balanced test tube. I'm going to put those opposite each other in the centrifuge, and I'm going to turn it on. And notice now, it's not jumping around, it's not loud, it's smooth. So, when we centrifuge something, we want to put it in there, and we want to let it run for about 2 minutes. We'll grab something right here. This hadn't been 2 minutes, but I'm going to stop it a little bit early, just to make sure that, because I'm not going to completely separate it, just for demonstration purposes. thing stop on its own. And when it does, it takes it a minute. We can pull out our test tubes. Now, our counterbalance test tube, let me just pour that out, put our test tube back here. And you notice our test tube that we want to separate now has two distinct layers. It has our top layer, which is liquid, we call that the filtrate, and our bottom layer, which is solid, we call that the precipitate. You want to make sure you know the difference in those two terms. And our filtrate has ions in it, looks like it has probably aluminum and chromium. Our bottom one has our nickel and our iron in it. So we want to separate the top layer from the bottom layer. And we're going to do that with a pipette. So we get us another test tube, and the proper method for separating these layers is we start by squeezing our pipette. We squeeze our pipette and we put it in and we suck the liquid out and transfer it to our second test tube. And what we want to do is squeeze as close to our precipitate, the bottom, as we can. Now, if you touch the precipitate, then you're going to get chunks in your filtrate. That's bad. Also, if you don't squeeze it to begin with, if you just put your pipette down there and then squeeze, it's going to blow bubbles. And when you blow bubbles, it mixes everything up. So, if you make a mistake and you've mixed everything up, so I've mixed all this up, well, how do we separate it again? Back in the centrifuge. So back in the centrifuge, we take how much we need to reseparate, grab us a counterbalance, add water until they're equal, and then opposite sides, and let it spin for a little bit. And again, you want to let that spin for about 2 minutes. I'm doing mine a little quick. Counterbalance. And you notice after I let it spin, I got nice separation again. So if you mix it up, all is not lost. You just throw it back in the fuge and reseparate. All right. So I'm going to pull off as much as I can there. All right, so now I have 2 test tubes. Now, key for this lab, to make this lab easy, is you organize all your test tubes and write what step you are on the test tubes. What I like to do is I like to label my test tubes A, B, C, D, and E. And then I'll write on my procedure that, well, this is in test tube A, and I'll write an A by that step, or I've transferred to test tube B, so I know what is in each test tube at each step. If you confuse your test tubes, then you're going to add the wrong thing to the wrong test tube and you're going to have to restart. Now, I have 2 test tubes here. My filtrate is in one test tube, my precipitate is in the other. And if you look closely at this, there's still a little filtrate in here. We want to save that. So there's a washing procedure that you have to do to make sure you get all your filtrate out of your precipitate. And what you do is you get some distilled water, and you add a certain amount of distilled water to it, usually about 20 drops or so. And you get a stirring rod, and you mix it up. And then once you mix it up, again, that's made the solid go back into the suspension, so recentrifuge. Do the counterbalance test tube, add some liquid to it, and back into centrifuge. Now, all of this that I've gone through is in this background paper here. So I've gone through the centrifuge procedure. I haven't gone through the precipitation completion, just add a little more to it. And what I'm doing now is on the back, I'm doing the removal of the filtrate and the washing of the precipitate. I'm gonna let this go a full 2 minutes. I'm gonna stop it early. All right. Now, so this right here is a washed precipitate. And once I wash this precipitate, ideally, most of the times what you're going to do is, again, pull this washing off. And on the first washing, we generally add it to our filtrate from to begin with. Now, if you have so much filtrate that your test tube's full, then you can discard this. But if, for most of you, you won't have very much filtrate from that first separation, so you'll want that first washing. Now, to make sure that our filtrate is completely clean, we're going to wash this 3 times. And again, the washing procedure is add some water to it, take our stirring rod, mix it all up, and then get us a counterbalance tube and centrifuge. Now, after the first washing we keep. But the second and third washing, so we really want to wash these 3 times. The second and third washing, that extra liquid on top, we're just going to discard it. It's not going to have very many usable ions in there. So again, we've washed it once, we've kept it. I've washed it a second time. I'm just back in here. Let this run for 2 minutes. And this is my second washing. So squeeze my pipetter, pull that liquid off, and that one is a discard. All right. Now, if you mess up the washing, that's one of the easiest ways to to get the things mixed up and to have errors in this lab. So make sure you're organized to make sure you wash it correctly. I'm going to wash it 3 times. Now, hot water bath. At one point in the lab, you have to heat, I believe it's your aluminum, over a hot water bath. And the hot water bath is just going to be a beaker that's on a hot plate. And this doesn't have much water in it, but we're going to pretend it does. Now, when you heat something, you're going to heat them in these small test tubes. The only time you use your big test tube is at the very first step. Everything else is done in these small test tubes. And this lab takes more than 1 day. So we give you these little stoppers to put on top of the test tubes to make sure that none of your stuff evaporates overnight or things don't spill. But when you put a stopper on a test tube, this creates what's called a closed system. And you never want to heat a closed system, and I'll show you why. I'm going to heat this. That's what you don't want to do. So I have some water in here, and I'm going to stopper this. So if I have my closed system, and I start to heat it, once the water gets warm, it's going to start to vaporize, and when it vaporizes, it's going to generate pressure. And pressure in a closed system is never good. Now, best case scenario, when this right here occurs, is that it just blows the stopper off. Worst case scenario is you end up with a bomb on the end of your hands and it goes everywhere. So, we don't heat a closed system. If we catch you heating a test tube with a stopper on it, we'll probably just kick you out of the lab. So, how are we going to heat on a hot water bath? So you're going to have, I can talk about it with this one. You're going to have a hot water bath, and the reason we use a hot water bath is that it doesn't heat quite as vigorously as flame. But the hot water is hot, there's steam coming off of it, you don't want to burn yourself. So when you heat on a hot water bath, you take your test tube, you grab it, and you're going to grab a second time with another set of test tube tongs. And it's going to make this like little configuration like this. And you're going to put that right on top of your beaker, and that way you don't have to hold it by the water. You can just watch your time. So that's how to heat a hot water bath. That's why we don't heat a closed system. I don't know where that went. There's probably glass everywhere. We'll clean it up. And we know now, like, make sure you know where you're pointing it. All right, so that is a brief overview of the background stuff. Now, last thing I really haven't talked about is our indicator solutions. Now, our indicator solutions, there's only going to be about 1 or 2 sets of these per room. They're going to be on the front, so when you need to use these, instead of like bringing them to your table, you're going to come to the front of the room where these are, and you're going to add these to your test tubes whenever you need to. Now, what an indicator solution does is it forms a complex with something in your solution that you're testing that either reacts with pH or it forms a complex that gives off a certain color or a certain characteristic. Now, one of the most common indicator solutions in chemistry is phenolphthalein. Now, we're not going to use phenolphthalein in this lab, but I have a little bottle of it here. So phenolphthalein is an acid-base indicator. So if I put some acetic acid, I have some acetic acid right here. If I put some acetic acid in a test tube, add a little water to it, and I add phenolphthalein to it, what you should see is, well, nothing occurred. Because phenolphthalein only indicates, it only forms a complex if the pH is greater than 7. Acid has a pH less than 7, so no complex. Now, if I were to add a really strong base of this, like sodium hydroxide, then what we can see is when the base is added, it turns a deep pink, fuchsia, purpley color. And that lets us know it's basic. Now, fun thing about phenolphthalein and its acid base is that, well, I can always change the color back if I want to. If I just got to add a little bit of acid. So that's what an indicator does. Now, we're using 5 different indicators in this lab. We are using one indicator for iron. Our iron indicator is potassium thiocyanate, which makes a nice deep red color. I don't know if you know, but iron particularly exists in the heme molecule in your blood, and iron is why your blood is red. So when we add our potassium thiocyanate to our iron test tube, if iron is present, it turns the color of blood. It looks deep, deep red. Our nickel is measured with dimethylglyoxamine. And when we add dimethylglyoxamine to our nickel, it's going to make a solid. So we can confirm nickel with dimethylglyoxamine in 2 methods. One, we can see the color. It's going to turn a nice pink color. And then we can centrifuge it and confirm that it's actually a solid. If you add dimethylglyoxamine, it turns kind of pinkish, kind of reddish, you're not sure, but you throw it in the centrifuge and it doesn't separate, well, you probably don't have nickel. If it makes a nice, solid separation, that's one way you can test. Our barium chloride reacts to confirm the presence of chromium. Now, if you remember me saying way back earlier when I was doing stuff with the big test tube, our sodium hypochlorite, it basically oxidizes chromium to a chromate ion. And barium chloride forms a pale yellow solid with chromate. It forms barium chromate, which is insoluble. Now, if you mess up the earlier part of the lab, and you don't form that chromate ion, you can have chromium, but chromium itself doesn't react with barium chloride. Only the chromate part, chromate ion does. So, got to make sure that you don't mess up earlier, so that you can make sure that you can get a solid. Now, you can centrifuge this, and you'll see a solid, and it has a certain color. Now, aluminum, our aluminum is special. We have 2 tests for the aluminum. The first test for aluminum is a a chemical called pyrocatch called violet. Sometimes you may just hear me say catch called violet. It's got a few different names. And this right here is I believe it's a chelator. It'll chelate the aluminum. But the pyrocatch called violet is a pH indicated and metal ion indicated indicator. So if you accidentally add one of these things that you're not supposed to your aluminum solution, it may change color even if you don't have aluminum. So it has to be a certain pH, and you have to have the aluminum for it to work right. Now, if you add the pyrocatch called violet to the aluminum, it should turn a nice deep blue. But if you have way too much base in there, it'll also turn a bluish color. So you have to make sure that you follow the procedure and add enough acetic acid when it tells you to, so the pH is correct when you do the test. Now, since it's a little finicky, we have two tests for the aluminum. The second test we have for aluminum is 8-hydroxyquinoline. Now, 8-hydroxyquinoline, when you add it to aluminum, doesn't change color. But what it does is it'll grab the aluminum, and it allows the aluminum quinoline complex, it can be identified with fluorescence under UV conditions. So in the lab, we're going to have a little box, and we're going to have these UV lights. And when it comes time to test your aluminum with your quinoline, what you'll do is you'll put it in the box, and the box blocks out all the light, and you'll shine a UV light to it. And if it glows, that's called fluorescence, and we know that there's aluminum there. If it doesn't glow, there's probably not any aluminum. And I'll make sure to show y'all this before y'all do the test, the procedure for shining it and what the fluorescence should really look like. So that is all of our indicators. We've gone over how to operate the centrifuge. Our stock solutions are known. How to heat a test tube in a hot water bath. How to never heat a test tube if it's closed, and to make sure that you're not pointing the test tube toward anybody. Ideally, if you saw the test tube explode, you would understand the importance of goggles. I'm wearing a lab coat as well because I don't want to get my clothes dirty because I have honors night in a few minutes. And we've gone over how the grading for the lab is. Now, for this test, here's what you need to know. Everything that I talked about on this first sheet right here, you need to know what parts of the lab are worth what grades. That may be a question. You really need to know what your grade is after a certain number of attempts. And you need to know, like, where's the quiz grade, where's the test grade. We'll ask you that. What else you need to know is pretty much everything on this background sheet. You need to know how many drops is in a milliliter. You need to know how to run a centrifuge, how to balance a centrifuge. What happens if your centrifuge is going crazy and is trying to jump off the table? You need to know how to heat a hot water bath. You need to know how to heat a test tube. You shouldn't point it at anybody. Never heat a closed system. You need to know, you don't really need to know what stock solutions you add at what step. That's what your procedure is for. We're not going to say, you know, what solution you add at step 14 in the lab. But you do need to know your indicators. So you need to know which ion your barium chloride is used for. What ion is your dimethylgloxamine used for? You need to know which indicator might cause fluorescence. So you need to know what ion each indicator is used for and which indicators are used for each ion. We may ask you, how do you find aluminum? Or we could ask you, you know, which ion will 8-hydroxyquinoline indicate. So that is all in our procedure, particularly all the indications on the back. So between these 3 pieces of paper and everything I've told you in this video, I don't think I've left anything out. If I have, I'll catch you up on Friday when I get back. You can study this, and on Monday, whoever wants to take their test first can test, and then we'll get started. One thing I will tell you, if once you take the test, you're going to be doing the actual lab in Ms. Dunn's room. So my room is going to be a study room, and Ms. Dunn's room is going to be a lab room. So you're going to be stuck in my room until you pass the test. Once you pass the test, then you'll go next door and you'll work in the lab. Once you're done with the lab, you've done all of it, and you've gotten all your grades, then you're going to come back over to the lab room. So you want to make sure you have plenty of time to do the lab, because you have until, I believe, May 16th to do the lab, and there's no advisory, and you can't stay after school because we're not going to let you. So you should have enough time to do the lab, do all this right here without being rushed. But you don't want to go too fast, because if you go way too fast and you get done in 2 days, which is possible, not very many people do it, but it is possible to finish in a couple of days, we're going to kick you out back over here to this room and make you study for the finals for the remainder of the lab. So you want to make sure that you take your time, you do everything carefully, but you don't want to spend too much time in the lab. We have, I think, 7 days of lab time to work. Most people can get it done in about 4 or 5. And if you have an EOC or an AP test, that's what we have extra time. But other than that, any other questions that you have, you can ask me when I get back.